So we have a definite integral that is unbounded on one of its limits because of the 0, which is an asymptote in this function. So this is an improper integral. First thing we do is change it to a proper, and we're going to write it with a limit. So a to 1. I'm going to write it as x to the minus 1/3 since we're going to be finding the antiderivative, dx. And then we make this a limit to compensate for the fact that we changed that to an a. And a is going to go to 0 from the right. The reason from the right is because we're coming from inside this interval to 0. So now we have the limit as a approaches 0 from the right, and we take our antiderivative, so we increase the power by 1, so that becomes a 2/3, and divide by the new power. Well, dividing by 2/3 is the same thing as multiplying by 3/2, and this is going to go from a to 1. So the 3/2 can be pulled out in front of the limit if you like. So we'll deal with the limit first because that's the most important part. And plugging these in, we have 1 to the 2/3 minus a to the 2/3. Now this doesn't depend on a, so this is just going to be 1. This does. Well, I can actually solve for this via substitution because putting in 0 doesn't cause any issues. This is just 0. So we end up with 3/2 times 1 minus 0, or 1, or 3/2. So we have a convergent improper integral, and it converges to 3/2.